Learning something new today.
Yeah, this is the last one. Yeah.
Alright, so we're on page 44.
One morning. Oh, we're going to miss Fridays or something.
Alright, so we're looking at 6.3. We're looking at exact ratio. Alright, so we're going to come up with a exact value for sine, cos and tan of 30 degrees, 45 degrees and 60 degrees. Okay, so first you need to consider is a right-angled isosceles triangle, two equal sides, 1 unit long, and two 45 degree angles. Alright, so consider the isosceles triangle, the right angle, 45 degree, and each of these sides are unit long. So, the first thing we need to do is write down the values of sine 45, cos 45, and tan of 45. Okay, so it doesn't really matter which angle we reference. Okay, so let's go to the bottom angle. So we label our three sides. Alright, so sine 45 degree. Alright, so now we need to write down an expression for sine 45. So, what is the three letters? What are the two letters, sorry, for sine? Sine is what over what?
O, H. Yeah.
O and H, okay, so we're given O, so it's 1, and H, what's H? Alright, so we need to use what to work out the length of that side? Pythagoras. So, H is going to be the square root of 1 squared plus 1 squared. It's going to be square root 2. Okay, so the square root 2 is an exact value. Alright, so sine 45 is going to be 1 on root 2. And that's what's called an exact ratio. Okay, we're going to do this for sine, cos and tan. The square root of 2. Alright, cos 45 degree. Okay, so what two letters for cos? A and H. Okay, so 1 over root 2, exactly the same. And tan of 45 degrees is what? What two letters?
1.
So O over A, so 1 over 1, which is 1. Okay, so in your notes of lesson space for the sine, cos and tan 45. The sine 45 equals 1 on root 2. Cos 45 is equal to 1 on root 2 as well. Remember, sine of theta is equal to cos of 90 minus theta. So theta is 45. Okay, so that means sine 45 must equal cos of 90 minus 45, which is cos 45. Alright, so that's why those two are equal. And tan 45 is 1. Okay, there's your first three. The next part of it, we now need to consider an equilateral triangle. What are the properties of an equilateral triangle again? All sides are equal, or angles are equal. Alright, so let's write some of that information in there. Alright, so we've got equal sides. Alright, I didn't really need to write the angle in there. Okay, but we'll write it there. Alright, so now we need sine of 30, cos of 30 degrees, and tan of 30 degrees. We also need sine of 60 degrees, cos of 60 degrees, and tan of 60 degrees. Okay? So, in order to do that, so each of my sides are going to be 2 units long. Okay, and the reason for that in a moment. Alright, so each of those sides are 2 units long. If I drop the perpendicular down from the apex, down to, it'll meet the midpoint, okay, at right angles. Okay, or in other words, if I draw a perpendicular from the base at the midpoint, straight up on an equilateral triangle, it will meet at the apex. Okay, now we could probably do a congruence proof to justify that, but we'll just take my word for it unless someone really wants me to go through it. Right, so we have the right angle there, so what's the size of the angle up here? 30, okay, so bisect as well, so that angle up there is 30. So, we've got the hypotenuse, which is 2 units long, okay, so how long is it from here to here? 1 unit, okay, we're doing a bit of geometry work. Right, so we also need to work out how long this dotted line is, okay, so there's another application of Pythagoras' theorem. So, what do I do? Let's call it x. So x is going to be the square root of the hypotenuse squared, 2 squared, take away the other shorter side squared. Okay, so we square root of 3. 4 take away 1, take the square root, and we can't simplify the square root of 3 any further from our surge topic. Alright. So, let's change that to a square root 3. Right, so now we've got sine 30, cos 30 and tan of 30. So, let's go. 30 is the angle we're referencing. So those 3 sides of that triangle. Alright, so sine 30 is opposite over hypotenuse, which is what values?
No, what am I doing?
Right, so sine of 30 is 1 on 2, so half. Cos of 30, what's the values for the fraction? Root 3 for the adjacent, and hypotenuse is 2. Okay, tan of 30 is what? Opposite over adjacent, so 1 on root 3. Okay, so there's another 3 exact values. Alright, so now we need to go 60. So again, look at the hypotenuse, which is still the same. Okay, so now the adjacent becomes the opposite, and the opposite becomes the adjacent when we're referencing the other angle in the triangle. Okay, for those who are here or watched the video, we did this when we did complementary angles about a week ago now. Right, so sine of 60, what are the values that we put into the fraction?
1
Okay, so the opposite and hypotenuse.
Where's the next one? Did you say you went Kyle?
Okay, and those from the complementary angles, sine of theta is equal to cos of 90 minus theta. Okay, so if I have theta is 60, 90 take away 60 is 30, so sine of 60 is equal to cos of 30. Okay, so those two are equal. Yep. Cos of 60 is equal to what? 1 over 2. So again, sine of theta is equal to cos of 90 take away theta. So if theta is 30, 90 take away 30 is 60. So sine of 30 will equal cos of 60. Or you look at the diagram, adjacent, which is 1 on the orange writing, and the hypotenuse is 2. Right, tan of 60. What are the two values for that fraction? Okay, so root 3, so the opposite over adjacent, so root 3 over 1, which is root 3. Okay, so now these values are summarised in that table in your notes. and this is what you need to know, those 9 values. Okay, so you can either, one or two things you can do. You can either learn them off by heart, which is what my teacher made me do, okay, which is obviously benefit, because if you don't learn them off by heart, okay, you're going to have to derive them, okay, then work them out. Alright, so let's do a quick table. Alright, so we've got sine, cos, and tan. We have 30 degrees, 45 degrees, and 60 degrees. Okay, so there's a table in your note. Okay, so this was 1 over 2, sine of 45, which is 1 over root 2, and sine of 60, which is root 3 over 2. Alright, so cos of 30, which is the same as sine of 60. Cos of 45, which is the same as sine of 45. And cos of 60, which is the same as sine of 30. Using the complementary angles that we did earlier this topic. Alright, tan, we've got 1 on root 3 for tan of 30. We have 1 for tan of 45, and then we have root 3 for tan of 60. So, you either need to remember that table off by heart, okay, or you can derive them from the triangles. Okay, so obviously remembering off the table off by heart will be quicker, okay, in the long run. Hopefully you will do enough questions in your examples that you will start spitting them out quickly, okay. Right, any questions? No? Okay, so everyone's understanding what we're doing? Okay, how they've been derived? Right, so let's look at some examples. So, simplify, A. Alright, so we've got 4 cos of 30 degrees times tan of 30 degrees. Okay, and this sort of work, when you see sine, cos and tan of 30 degrees, 45 degrees and 60 degrees, okay, you will be relating to this table here, okay? So every time you see that, this is what you're going to be doing. Alright, so 4, what's cos of 30? Cos 30. Alright, so 4 times root 3 over 2. And what's tan of 30? Okay, 1 on root 3. Okay, root 3 cancels. 4 cancels to 2, 2 cancels to 1. So we have 2 times 1 over 1, which is 2. If you put that in your calculator, 4 cos 30 times tan of 30. Calculated in degrees mode, Michaela. Okay, 4 cos 30 times tan 30. You should get 2.
Yes. GG. Yes.
Okay, it won't always work like that though, okay? Alright. B. Alright, so we have sine squared of 60 degrees plus cos squared of 60 degrees. Alright, so it's a new notation. So let's write it over the side. So sine squared theta. Okay, this means sine theta or squared. Alright? And when you have sine squared, sine cubed you can have, sine to the power of 4. Alright, so sine cubed, we'll be looking at extension 1 maths. Sine cubed, cos cubed and tan cubes. Alright, so that's the notation. So, this means sine of 60 degrees or squared plus cos of 60 degrees all squared. Alright, so what's sine of 60? Okay, root 3 over 2 squared. And what's cos of 60? Half. A half all squared. Alright, so what's root 3 all squared? 3 over 4. And what's half squared? What's 3/4 plus 1/4? And that will be one of the rules that you'll be learning in a future lesson. Okay, that sine squared theta plus cos squared theta is equal to 1. Okay, no matter what value for theta. Alright. That covers exercise 6.6. Alright, next section, 6.4. Angles of any magnitude. So, one of our first lessons that we looked at in trig, or a recent lesson, I can't remember now, we looked at a number plane. Okay, we referred to those in quadrants, okay, and that's what's going to be important today. Right, so in the notes, it's got a diagram. Okay, so we've got our number plane, x and y, okay, from the top left, okay, going anti-clockwise, will be the reference for those quadrants. Okay, so if I were to plot point, okay, and have a coordinate, alright, this must be an x value must be greater than 0, and also the y value also is greater than 0. Alright, if I had a coordinate. If I had a point in the second coordinate, alright, it means my x is less than 0, but my y is greater than 0. Okay, so the x and y values if it were plotting points for a graph or something similar. Right, third quadrant, x is less than 0, y is also less than 0 because they're both negative numbers for a point in the third quadrant. In the fourth quadrant, we have our positive x value, but we have a negative y value. Right, so last lesson we looked at also bearing. Alright, bearings start from true north, which is pointing directly upwards. Okay, so this is bearings. Okay, this is north. Never eat soggy Weet-Bix. Don't do that, it's seriously not nice.
No, that's pretty good.
Right, now the bearing is a 3-digit reading, okay, starting from true north. Okay, so this is what we did last lesson for those who weren't here. East, okay, because this is a right angle, so if we measure the angle clockwise, we can have it 90 degrees. So the bearing of east is 090. Okay, it is a 3-digit number. 180 degrees, 270. Back to north, which can also be viewed as 360 degrees. Okay, a 3-digit reading in reference to the point in the middle. Right, this is also slightly different, okay, because the first quadrant starts on this x-axis here, okay. To measure an angle in here means the x value is going to be 0 on the axis side, or 360 degrees. Okay, so west at 270 degrees bearing. As we go in from the first to the second quadrant and we go around all these axes, okay, this is going to be 90 degrees up the very point. So from X, measure 90 degrees, get to there, measure another 90, this is 180 degrees, and then down the bottom, 270, all the way back anti-clockwise till we get to 360. Alright, so bearings start from true north, which is will always point north, or will always have a reference where north is. Okay, so if you happen to get a question where north is out this way, it should be labelled. Okay, but I've never come across that. Okay, so it starts from true north. It is an angular measure in a clockwise direction. Okay, from 0 right around to a revolution of 360 degrees. Okay, when we are looking at angles of any magnitude, okay, the x-axis, positive x-axis is a starting point, because from that defines our quadrants. Okay, so from here to here, 90, here to here, 180, from here right around to here, 270. Okay, any questions on the interpretation of those? Okay, is everyone following what's going on, how it's interpreted? Alright, so 4 things we need to look at, all 4 quadrants. Right, so first, we look at the first quadrant. Okay. These are all in your notes, so if you want to label your diagrams in your notes, you're welcome to. Okay, you can do what you want with those. If you don't have your notes, you're going to have to quickly get that reference there. Right, so we've got the positive x value and we've got the positive y values. We're just taking that section of the number plane, okay, and putting it down here. Alright, we pick a point, okay, so we'll label it capital P, with the coordinate will be a positive x value and a positive y value. Okay, so that means out from the origin, we've got a positive x value out here, okay, so this means the distance will be x units. Okay, up here, we've got some value y to meet that point, upwards to get that point here. Okay, so therefore from the origin up to that point, the distance is y units. Alright, and then if we were to connect that point with a straight line to the origin, okay, so from here, if we were to treat it like a bearing, we've gone up a certain degree. Okay, so let's call that variable theta. Okay, this will be r, okay, r for the radius, for circle, and we consider it as a circle being mapped around. Alright, and then also this part of the triangle is, that side of the triangle is y unit, with a right angle there. Okay, so the magnitude of the point P here, where they're both positive, for all 4 quadrants we're about to go through, will define each of our ratios in the 4 quadrants. Okay, so sine theta, cos theta, and tan theta. Alright, so in my triangle, from the right angle up to the hypotenuse is the point to the opposite side of the hypotenuse. From the marked angle to the opposite side, which is opposite, and the side left over is an adjacent. Okay, so sine theta, which is opposite over hypotenuse. Okay, so yes, you need to know these well. Okay, so the opposite had length y units, and the hypotenuse had length r for radius. Okay, so y over r. Right, cos of theta. So we've got adjacent and hypotenuse. Okay, so the adjacent is x units from the origin out to the end of the x-axis where it goes up to the point. We've got x, and the hypotenuse is the same, which is x over r, not 10. Right, tan of theta. Okay, so the ratio with the 3 letters is opposite over adjacent. Okay, so the opposite is y and the adjacent is x. Okay, this will make more sense in a moment. Okay, as well as this statement. that any angle between 0 and 90 inclusive, okay, so this theta was 0, it will be straight on this point here. If this angle was 90, it will be straight up there, okay. That means any value of theta between 0 and 90 inclusive, okay, we are always going to get a positive result back. Alright, that will make more sense in a moment. Alright, so next, quadrant 2, so second quadrant. Okay, so I'm going to redraw that first one, okay, and include the second. So this is the first, and this is the second. Okay, these are straight from your notes. Alright, so this is x, this is the y-axis. Okay, so incorporating that diagram again, okay, so we had that point P, so some x and y value which are both positive over there, okay, for the radius. Here we keep that same distance radius, so we keep that as a variable, okay, and we pick the second point, alright, so we've got a point about here, and we're going to call it P subscript 2. Okay, what can you tell me about the x and the y value for a point in the second quadrant?
More greater than 0 for y.
So it's negative x and...
Yep, so a value less than 0 for x, alright, so we're going to reference that as minus x, alright, and a value greater than 0 for y, so we'll call that y. Alright, so let's connect that back up to the radius. Right. Right angle there, right angle there. Alright, so we've got theta there, so a reference from our first diagram. Okay, now the angle formed this line, so we go back to our bearings understanding. Alright, the angle from the x direction, which is at 0 degree, and then we go right around to that line there. Okay, so we're going to keep that theta the same, so to keep the magnitude the same for x and y, but the sign different, okay? So this angle here is going to be 180 take away theta. Right. So sine of 180 take away theta, cos of 180 take away theta, and tan of 180 take away theta. Okay, so instead of going from 0 right around to the line that's formed by point 2 in the origin as 180 take away theta, okay, we're actually going to go back the other way. Alright, so we're going to go back this way, and we call that theta. Okay, the angle there. Okay, because the radius is the same, and magnitude of x and y are also the same with opposite signs if necessary. Okay, so what that will mean is sine of 180 take away 0 is going to be the same as sine theta. Okay, because we're going backwards from this here over to that side there from the negative x-axis. Okay, right. So sine theta. Okay, so label our three sides of our triangle. We've got the hypotenuse, which is of radius r. We've got the opposite. Okay, so this is distance up y units. Okay, in the positive direction, and that's the opposite. And then the leftover, it is x unit, but because we're considering in the negative direction, okay, we're going to treat that as a displacement. Okay, displacement is the reference of a point from an origin. Okay, now we have to do this because we're going to consider the sine. The sine of theta, which is opposite over hypotenuse. Okay, so the opposite is still y, and the hypotenuse is r. Okay, so the radius is always positive because it is a distance out from the origin to the point. Right, so cos of 180 take away theta is going to be the same as cos of theta going back the other way. Okay, so going from here to here, going to be the same because of the flat horizontal plane there, going back the same angle mark theta that we did in the first quadrant out to that point. So that's going to be A, adjacent over hypotenuse. Right, now the adjacent down here, it is the distance of x units, but because of the position, it's in the negative direction. Okay, so instead of writing x, we're going to write negative x. Okay, we're talking about displacement. And those of you who do physics will do more on that, as well as doing it here later in your HSC course. Alright, tan of 180 take away theta, which is the same as tan of theta, which is opposite over adjacent. Alright, so displacement is the positive y unit up for the opposite, and adjacent, which is distance is x, okay, but the displacement is negative x. Now, what that means is a value of sine of an angle between 90 and 180 inclusive, okay, will return a positive value. The value for cos and tan of an angle between 90 and 180 inclusive, okay, will come back as a negative answer. Alright, so go to your calculators, put cos of an angle greater than, put it greater than 90, less than 180, pick a value, put it in your calculator, everyone should come back as a negative value. Yep, do the same for tan, do the same angle, and go tan of that same angle. Again, should be negative. And do the same for sine. Sine of 100, whatever the angle you did. And this time you'll get a positive value. Okay? So, you're not required to understand how it derived necessarily. Okay? But it does help with your thinking for further things that we do in trig. But what you need to get out of it is the size of the angle in each quadrant, and whether it's positive or negative for each of your sine, cos or tan. Okay? Any question? Right, let's try the third quadrant. Right, so we picked a point P, x comma y, so it's theta away from the x-axis up. Right, so I'm going to keep that value. Right, so in the angle in the third quadrant, so of course the distance r for the radius of the circle, if we were to draw a circle around the centre point of the origin. Alright, that means there's going to be a point 3 down here. Alright, so what are the values of x and y in the third quadrant? Both negative, okay? The negative x and negative y. Alright, so while the displacement is going to be negative in both cases, the distance from the origin out to that point is going to be positive. The distance always positive, displacement can be negative. Alright, so keep it angle theta. Okay, and then referencing this, remember our x-axis is at 0 degree, the positive y-axis is 90, this is 180, and this is 270. Alright, going anti-clockwise from the horizontal. So, if I were to draw this around here, what's the value of that angle in relation to theta? 180 plus theta. Okay, so we've got the marked angle theta here, which is vertically opposite this angle here. Okay, go from 0, 90, 180 plus that extra theta down there. Right, so we've got the radius still the same, r, because the magnitude of the points are still the same with the opposite sign. Right, so in the third quadrant, sine of 180 plus theta is going to be the same as sine of theta. Okay, so now we've got a triangle from this axis down. Okay, so from this axis down, we've set at the same angle. Okay, because these x's and y's are still the same, be the same in all four quadrants, therefore the angle will also be equal. Alright, which is opposite over hypotenuse, and remembering both those readings are negative displacement, the radius is the one you take constant value r. Alright, so labelling, hypotenuse, opposite and adjacent. So the adjacent is x units and the opposite is y units. Right? Distance, not displacement. Okay, the displacement, because they're going both in the negative direction, mean that opposite over hypotenuse, which is going to be negative y, because we're displaced in the negative direction y unit, okay, over positive r. Okay, the radius for the circle will stay constant positive. Right, cos of 180 plus theta. Okay, so the angle from here all the way around to here is going to be the same as the angle referencing the negative x-axis down to the angle there, which is going to be cos of theta, which is A over H, which is our normal cos. Alright, and in reference to our diagram, it's going to be x on R, but the x is the negative displacement. So negative x on R. Alright, so tan of 180 plus theta. Okay, so from the positive x-axis right around, we're going to take it the same as from the negative axis down. So there's going to be tan of theta, which is going to be opposite over adjacent. Okay, so opposite is y units for distant and x units for the adjacent. But again, we take the displacement, so negative y on negative x, and 2 negative become a positive. Right, go to your calculators. Pick an angle between 180 degrees and 270 degrees. Do sine, cos and tan of that same angle and tell me what magnitude of your answers you get, positive or negative. The angle between 180 and 270, take sine of the angle, take cos of the angle, and then take tan of that angle.
So it's like positive, negative, negative.
As in tan is positive. Yeah. Okay, so that means an angle between 180 and 270 inclusive. If you take the sine of that angle, it's going to be negative. If you take the cos of that angle, it's also going to be negative. If you take the tan of that angle, it will come back as a positive value. Okay. Fourth quadrant. We're having fun?
Yes.
Oh, it's interesting. It's very
I
interesting.
don't remember all this because this is Great.
Yeah, like I said, you're not required to derive this at all. I'm just showing you because I think it's interesting, and as well as it'll come, if you can get some sort of understanding here, it'll come useful in the later part of trig. That's why I'm showing it to you. As well as for the more brainy people in this class, get ready for your extension 1 part of your trig. Alright. And that is a lot of fun for you. Alright, so from the first quadrant, remember we picked that point x, y, made that right angle, there was theta, radius r, x, y. Okay, so again, in point in the fourth quadrant, we're going to call it P4. Okay, what's the magnitude of x and y there?
X minus 4.
Alright, so we've got x, a positive x value, and a negative y value for point in quadrant 4. Okay, so again, because of the same magnitude but opposite sign, like different sign, alright, this will mean it'll be a negative, it'll be the same angle at the centre. Okay, from there. So, the displacement from here to here is positive, the displacement from here to here is negative. Okay, in other words, from here to here is negative. So, sine, so going right around here, what's an expression for that angle in relation to theta?
360 minus theta.
Good, 360, which is revolution, take away that angle there. Sine 360, take away theta, which is going to be the same as sine of theta in the fourth quadrant, considering the displacement. Okay, which is opposite over hypotenuse. Right angle, hypotenuse, opposite and adjacent. Okay, so this is going to be my negative y, this is going to be my positive x, and this is hypotenuse r. So opposite over hypotenuse, which is minus y on r, considering the displacement. Okay, do cos and tan. Because of 360 take away theta is going to be the same as cos of theta in the fourth quadrant. Okay, so cos is adjacent over hypotenuse. We have a positive x value, and the radius is also a positive quantity. So we have a positive value for cos in the fourth quadrant. Tan of theta, tan of 360 take away theta, which is the same as tan of theta in the fourth quadrant. So opposite over adjacent, which will be negative y on x. Alright, pick a value between 270 and 360. Alright, take sine, cos and tan of that value and note the signs of your answers.
Funny!
So, sine and tan are both negative, cos was positive. Yes?
Yes. Alright, Robin.
What's time now?
He said more, didn't you?
Less than 360, more than
Oh, yeah,
370.
Alright, so let's summarise that. So do another number plane. Alright, so we have the first, second, third, and fourth. Okay, so all are positives, all sine, cos and tan of an angle in the first quadrant is positive. Okay. Now in the second quadrant, sine is negative. Okay, in the third quadrant, 10 was negative. And fourth quadrant, sorry.
It's the other way around.
Sorry. Sign is positive. Sorry. Tan is positive and cos is positive. Okay? So, to summarise, capital A in the first quadrant, everything's positive. Capital F in the second quadrant, only sign is positive. Capital T in the third quadrant, only tan is positive. And capital C
Ow.
in the fourth quadrant, because tan cos the only thing is positive. Okay? All students take calculus. Okay? It'll be your way of remembering. First quadrant, all students take calculus.
Take crap.
Just cause.
Okay, so if you didn't quite follow the working, okay, that's okay. This is the end result that you need to know. Okay? And we'll look at the application of this next lesson. Okay? If you did understand that process, that will help you, particularly your extension students, when we do the extension topic. Okay? Why I showed everybody. Right. Perfect time.
Yeah, it comes to take the new drug.
That was pretty wacky. Is you finding it any wacky? You finally
Alright, Kyle and Bo, let me see you both before you leave for lunch.
Okay.